In this video, you will learn the fundamentals of creating any simple game using the free software Blender. And for this example, we're going to use the old school snake game, in which the goal is to eat as many apples as possible while not eating your own tail. But before we start creating, it would be good if we take a look at what is the process of creating a game in Blender going to look like. So the first step that we should think about before creating the actual game is what are the components of the game. And in our case, that's going to be the snake, the apple, and the playfield. And the second thing is, what are the rules the game has to follow so that it actually works? And in case of the snake game, one of the rules could be that the snake is only allowed to move one step at a time, and not two steps, for example. Or that the apple is not allowed to spawn at the same position that the body of the snake is. These are kind of rules that the game should follow. There are more, but we'll take a look at them later. Then the third step is, what are conditions that would make you fail the game? For example, the snake eating its own tail, then it's game over. Or when the snake moves out of the playing field, then it's also game over, of course. It's important to write those rules down beforehand so that you don't forget those rules later in the progress. And then the final thing is, what information should be displayed while playing the game? For example, the live score of the player, or showing game over when it should be. So now that we have a good overview over the steps we're going to take during this process, it's time to create the game. However, before we start, did you know that my new book, The Big Notebook, is available on Gumroad right now? It's a book that explains in detail every single note within geometry nodes using real-world examples you cannot find anywhere else. So definitely check it out after following this tutorial to grow your knowledge about geometry nodes even more and become a master very quickly. And now, let's actually start with the tutorial. So let's start off by going into geometry nodes over here, and let's click on the cube and let's click on new to create a new geometry nodes. And we can call this snake game. We can remove the group input because we don't actually need the cube. We're going to create everything within geometry nodes. So what we're going to start off with instead is Shift A and add in a simulation zone. And we can connect the simulation output with the group output. In the simulation input, there are three components that I want to add in as geometries. We already have one geometry socket, so we can simply click on the simulation input, press N to make this sidebar open up, and then go to Node. And then in the simulation state, you can rename this to snake head. Then you can click on plus over here to create a new geometry socket, and this is going to be the apple. And then the third one, you would think that's going to be the playing field, but actually it's going to be something different. We're going to click on plus over here, and we're going to name this snake tail, because we need to have the snake head as a separate thing as a snake tail. Later in this video, it will be more clear why we do the snake head separately from the snake tail. For the snake head and the apple, we're going to add in two points nodes. So take one and press Shift D to duplicate it. And for now, if we just ignore the simulation zone for a moment, we can add in a join geometry, join them together like this, so that we have 2 points over here, give them a new position like that. Okay, let's say that this one is going to be the head. So let's make the radius a little bit bigger so that we can identify that very easily as the head. And the starting position of the head and the apple should be randomized. But not just randomized, no, they should get a random starting position perfectly on a face of the playing field. But we don't have the playing field yet. This playing field is going to be a grid node. And if you want, we can also join this together so that we can see the grid. And right now for this grid, if you make the vertices higher, for example, you cannot really see a difference. If you want to see a difference, you can go over here into the overlays and turn on wireframe so that you can actually see where the faces of the playing field are. And later we're going to use this grid a lot more. And since I want to make the size X, size Y, vertices X, vertices Y as procedural as possible, we are going to import a group input node. And then we connect the size X, the size Y, vertices X, and vertices Y, so that we can easily change them over here in the modifier of the geometry nodes. Now let's choose for the snake head and the apple random faces to start off on the grid. And to do this, we're going to do a sample index node so that we can get the position of each face. So let's set this from float to vector because the position is going to be a vector. And let's set this from point to face since we want to have the position of each middle point of the face. let's connect the grid with the geometry like this. And as the value over here, we want to get the position value of each face. As the index, we kind of want to get a random value, because now the index is on 0, which means it will take the position of the face that has index 0. But if we take a random value for this, it will take the position of a random face, which is really good. However, the range of the random value should not be like 0 to infinity, for example. No, it should be 0 to the maximum number of faces. And to get that information, we're going to do an attribute statistic node. And we want to get the maximum number of faces from the grid. So we connect that over here. And then if you insert an index node, we can get the minimum index and the maximum index of all the faces of this grid. And now to select one randomly, we can do a random value node, which we set on integer because the index value is an integer value and not a float value. And let's set the min like this and the max like that. And now we're choosing a random value between all these faces. And this we can connect with the index like this. And then this is the position of a random face, which we connect with the points node. This doesn't work yet because it now goes exactly in the middle. That's because in the attribute statistic, we should set it from point to face. And now if we make the radius a bit lower, maybe, you see you can get with the seed value different starting positions. I'm going to make the radius of the snake head 0.1 actually, and the radius of the apple I'm going to lower down like this. And now to do the same thing for the apple, you can actually take the position node, the sample index and the random value node and do Ctrl-Shift-D to duplicate them, but keep the connections and then connect that with the points. And then of course you have to set a different seed value for the random value to give the apple a different position than the snake head. Let's make it that we keep our overview a bit. So let's keep the grid over here and this one too. And then let's move this over there and this over there. And if you want, you can even put a frame around these things. So if you take them and press Ctrl-J, which you can give a label like apple. Like this, and you can, in the properties, you can make the label size bigger. And you can do the same thing over here. So you take this, Ctrl-J, and give it a label, snake head. Now we can actually delete the join geometry over here, and we can connect the snake head with the simulation input snake head, and we can connect the apple with the simulation input apple. And now it's time to really simulate this thing. However, if we connect snake head like this, we only see the snake head, right? That's not really good. So let's add in another join geometry and let's join the apple with this. But we don't see an apple. That's because over here within the simulation input and output, the apple is not connected like this. And then we see the apple. And if you want to see the grid too, what I recommend is taking the group input and the grid over here and press Shift-D to duplicate it. And since we do it procedurally, this is basically the same thing. So if we connect this like that, then we see everything again. And now let's also make a little bit more space for ourselves because we are going to need it. What I also recommend is that in this view, you press numpad 7 to go into top view so that you can see the grid from the top. It's way easier to simulate the snake game like that. Now, the first thing that I want to do is that the snake head moves every 12 frames to a new face that is next to it. And to do this, we're going to first do a set position node. Otherwise, we will never be able to move the thing in the first place. And then as the offset of the set position, we can do a mix vector node, which we can plug in like this. Okay, we have three values over here, the vector, the A and the B. The A, we keep it as 0 because that means that it should stand still. And the B is going to be a new direction that it should move to. And the vector is going to indicate that it's going to do that every 12 frames. So if we put the x-axis of the B on 0.1, for example, then you will see it will already start moving. And if you put it on 1, you see it will start moving infinitely. But let's make it that it changes every 12 frames. And we do this by adding in a scene time node, from which we have the frame count. And then we take a math node, which we set on wrap. And what this does is if you put the frame value into the value, and the wrap function basically puts out a value between 0 and 1 from the frame 0 to 12. So from frame 0 to 12, it will count from 0 to 1. And then after 12 frames, it will start counting again. So that makes it that every 12 frames, we go from 0 to 1. So every time it comes to 1, it should move the snake head. So to do this, we can do a compare node. And if we set this to equal, we can say, okay, every time this red node is equal to 1, move the snake head. And now if we press play, every 12 frames it moves the head. And no worries yet that it's not like perfectly within the faces of the grid. We'll fix that later. Because this B value, we're going to make that an attribute called direction. So if you do a named attribute node, which you can set from float to vector and then name it direction, you can connect it like this. However, at the moment, this direction value is nothing, right? We are not assigning anything right now because we haven't created this direction value yet. And to create this direction value, we actually want to make more space like this. And to make the direction value, we can do a store named attribute. And the store named attribute, we're going to set this on vector because the direction is a vector. And then let's name this direction. And in the naming of this, it is important that you take a look at the capital letters, that it's perfectly the same written over here and over there. So now we're wondering, what should this direction value actually be? For that, we're going to need a controller, like a PlayStation controller or something like that. And the controller is going to be, if you press Shift A over here, an empty plane axis. And you can move that over here and make it smaller a bit, of course. That's completely fine. But this empty is going to be our controller, which will tell us where the head should move to. Because we can say, okay, if we press G, the head should go over here, it should go up, and over here it should go to the left, and over here to the right, and over here down. But we need to identify that within geometry nodes, of course. So let's click on the grid again, and actually to not lose our geometry nodes by clicking on the empty, we can click on the grid, and over here, click on this pin option. So that if you click on the empty, the geometry nodes will not go away. So now if you click on this empty, we can go over here and actually name this like controller. And to have control over the controller in geometry nodes, we can drag it into the geometry nodes like this. And the thing that we're most interesting about within this is the location of the controller. Because let's say if we move the empty over here, the output should be 0.1 because the x-axis is 0 and the y-axis should be 1. And over here it should be 1.0 or -1 over here or -1 over there. So now if we do Ctrl-Shift-Click on the object info and we add in very quickly a points node on which we also do Ctrl-Shift-Click, we can over here in the points, we can preview the location of the empty. However, you see that this location is always a value between 0 and 1. It's never like perfectly 1 or -1. No, it's like a float value between those things. We want, for example, for the fixed axis that when the x location of the empty is higher than 0, it should be 1. And if it's lower than 0, it should be -1. Same for the y-axis. And to do this, let's remove the viewer for a moment, because what we want to do is we want to extract the x-axis and the y-axis from this location with a separate xyz node. And if you connect the location with the vector, we have control over the separate x, y, and z. Later, when we're going back to the store named attribute over here, we're going to combine those again into a vector. So we're going to do a combine xyz node. So let's connect that like this. And let's move the points node to here. And let's preview this. So let's do Ctrl-Shift-Click and Ctrl-Shift-Click like that. And now we want to make it that when the x location is higher than 0, it should be 1. And if not, it should be -1. And we're going to do this with a compare node. Because we're now saying, okay, if the x location is greater than 0, then with a mix node, we can put either color A or color B. Well, if it's greater than 0, it will be color B. So we make this 1. And if it's lower than 0, then this one will be false, so it will be A. So let's make this one -1. And then you will see when it's over here, it's -1, and over there, it's 1. Let's do the same thing for the y-axis. So we're basically going to take these two nodes and press Shift-D to duplicate them, connect the y-axis with the greater than, and connect the mix with the y. And now you will see it's always either 1 or -1. However, if I put the empty over here, you see the output is 1 and 1. However, what I want is when it's over here, it should be 0, 1. Because otherwise the snake head will go in a diagonal line like that. And that's not really what we want. So what we should say is, okay, if the absolute y location of the empty is greater than the absolute y location of the x-axis, then it should take this vector. Otherwise, it should take this vector or this vector. And we're going to do this by creating another greater than node. Then we can say, okay, if the x-axis is greater than the y-axis, make the y-axis 0 so that it chooses either this one or this one. Let's make a little bit more space. And let's then add in another mix node for both the x-axis and the y-axis. And if you connect this one over here and also over there, then they are both controlled by it. Now, if this one is true, we want to make the y-axis 0. And also if this one is true, we want to make this one 0. But for that, we will have to switch the A to the B like this, and then make this one 0. Otherwise, it's not really going to work. However, at the moment, it still doesn't work, because if I put my empty obviously over here, it's closer to this point than to this point. However, it still chooses in the viewer this output. That's because we're also working with negative values, and we need to take in the greater than over here the absolute values of these. So any negative values should become positive values. So to keep our overview, we can hold down Shift and right click to make a joint over here. And maybe let's put it like this. And now let's add in a math node. And for both the x-axis and the y-axis, we set it on absolute like this. And then you will see that it will work. So now it's over here and it's -1 and 0. It's over here 0 and 1. It's over there 1, 0. It's over there 0, -1. Perfect. From here we can remove the points node and the viewer node. And let's connect the combine XYZ with the store named attribute so that we update the direction attribute over time. And then let's also take this whole thing over here and let's press Ctrl J to make it a frame. And let's place that over here. And let's name this frame something like controller nodes. And let's make it bigger as well. And now if we start pressing play, you will see that it does kind of work. However, these steps that it takes are way too big. What we need to do is we need to scale those steps down according to the amount of faces that it consists of. So for example, the length of this one is in this case equivalent to 1 meter. And we have at the moment 1, 2, 3, 4, 5, 6 faces. And if we take a look over here in the vertices X and vertices Y, that's on 7. So the number of faces is always this number -1. And to scale the direction from the controller down to the number of faces that we have over here, we can do a vector math node, which we set on multiply. And then to get this information, we want to do a group input node so that we have those sockets. And then we want to do a separate XYZ. And then we want to do a combine XYZ again so that we have control over the separate XY and Z sockets. And basically the value that we want to scale it down with is 1. So 1 meter divided by the number of faces that we have. And the number of faces, as we saw earlier, is this 7 -1. So let's do that first. Let's do a math node and let's set this on subtract. Let's make the x-axis -1. And now we want to do 1 meter divided by this subtract node. So let's take another one and let's set this on divide. And let's do 1 divided by this value. And this is going to be our x location. And we're doing the same thing for the y. So we take both of them and we do y like this and this one on the y. So if we press play, then we see that it doesn't really work because I made a little bit of a mistake. We should not put the size y and the size x in there. No, we should put the vertice x and the vertice y over here. And then you will see that it actually starts working. But I hear you thinking, what if we make the board bigger? So what if we make the size x bigger like this? Well, yeah, then you see it doesn't really work anymore. That's because the scaling part of the steps is not dependent on the size X and the size Y yet. This is very easy to fix. The only thing you have to do is connect the size X into the divide socket like this, and the size Y into the divide socket like that. And this way, what we're doing is instead of 1 meter divided by the number of faces, we do the actual size of X divided by the number of faces. And then you will see that it does work perfectly fine. And this, let's move that inside of this grid because it kind of belongs together. Let's now make it that every time the snake head eats the apple gets a new random position. So to do this, we're going to make a little bit more space again, and we're going to take this set position and we're going to Shift D it and place it onto the apple part. And the system to give it a new random position, we kind of already have that over here. So let's take the group input over here and the grid and the attribute statistic and the index and also the random value, the position and the sample index. And let's press Shift D to duplicate this. And by the way, if you want to get this out of the frame, you can press Alt P. And this is basically going to be our new random position. So if we connect this with the position, then if you press play, you see, yeah, nothing really happens yet. It's not really creating a new position. That's because the seed value over here stays the same the whole time. Let's make the seed value dependent on the scene time. So if we do the scene time node and we set the frame as the seed, then you will see it will go crazy. It will, for every single frame, it will give the apple a new position. However, the changing of the position of the apple should only happen if the distance between the head and the apple is 0. And to calculate that, we can use a geometry proximity node, which we set on points because we're working with points over here. And the target is going to be the snake head. So let's take this set position node right over there, because we want to calculate this proximity after we determined a new position for the head. And then for the distance over here, we do a compare node and we can say, okay, if the distance is equal to 0, then change the position. So let's see what it looks like. It moves, and then boom, it creates a new position for the apple every time the head touches it. Let's make this maybe a little bit more beautiful. So let's move this a bit out of the way and let's move this over there. Yeah, that looks a lot better. And let's move this over there. And we can also give this a frame with Ctrl J, and then let's name this new position apple. However, every time we eat an apple, the snake should grow. So the way we're going to create the tail is with, as you already saw, with this geometry socket over here. Every time we eat the apple, we want to transfer a copy of the snake head onto the tail, so that it will look like the snake will consist of a lot of points that are next to each other. It will make more sense when we're actually going to do it. So let's do it. Let's connect the snake tail all the way with the end part of the snake tail over here. We'll make it a little bit easier. And to determine what the length should be of the tail, we want to create an attribute that is the length. And this length attribute should go up by 1 every time we hit the apple. So that attribute, we're going to create that on the snake head attribute. So if we do a store named attribute node and we name this length, and let's keep this on float and point, and then this value, we want to update the length over time. So we want to do a named attribute over here. And then as the named attribute, we do length and we connect that like this. And now basically we can say, okay, if we do a math node and we set this on 1, and now we're basically adding a value of 1 every single frame to the length. But that's not what we want. We only want to add 1 if the head touches the apple, of course. So what we're going to do is take this geometry proximity and the equal node over here, Shift D them, and this time instead of the snake head as the target, we want to have the apple as the target. So let's go over here to the beginning of our simulation input and go over there and connect it with target. Now that I'm thinking of it, we can actually move all of this a little bit closer so that it's easier to connect all the nodes together. And now every time the head touches the apple, the output of the equal node will be 1, and that's what we want to add to the length. And now let's also name these nodes. Let's do Ctrl J and name them calculate length. Now let's go back to the tail part, because now we're calculating the length already. That's good. We're going to take a look at that later. And for the tail part, basically what we first want to do is to add a snake head to the tail part every 12 frames. So let's do a join geometry on the snake tail parts, and let's take the head and let's connect that with the join geometry too. And let's also over here in the back connect the snake tail with the join geometry, of course. Otherwise, we're never going to see the tail. So if we now press play, then you will see an infinitely long tail is created by the snake head. We don't want this, of course. Two things we want to do. We want to delete these points after a certain time. This certain time is dependent on the length value over here. So basically what we want to do is for each point, we want to track the age of it. And to track the age, we can take this store named attribute, shift D it to this one, and we're going to name this one age. And this age value, we're going to do a named attribute again. And then if we do age like that, we can connect this with the value. And each frame, the age should go up by 1, of course. So let's do a math node and let's add 1. And let's make a little bit more space again. And let's name this the age tracking part. Age tracking, like that. So now that we have the age, at some point the age becomes bigger than the length over here. And what we want to do is deleting each point after its age is bigger than the length. So if we do a delete geometry, we can also do a named attribute, which we set as age, and then also another named attribute, which we do length. And then we can do a compare node, on which we say, okay, if the age is greater than the length, delete the geometry. However, right now, each point will immediately be deleted because the length now goes almost like every single frame. But since the snake is moving every 12 frames, we have to multiply over here this length value by 12 so that we have the right scaling for the length and the age. So if we do a math node, which we set on multiply, and we multiply this by 12, then this will happen. Now, if we move it towards the apple, you see every time we're eating the apple, the snake becomes 1 unit longer, which is perfect. So we can now also take these nodes, Ctrl J, and name them delete after certain time. If we now start playing and we get a length of 1, you think there are now 2 points over here, right? However, if I do Ctrl Shift click over here on the snake tail, we can see that there are in fact 12 points only over here. This is not good. This is because before the join geometry, every frame we add in a snake head. And then it looks like it's 1 point, but in fact it's 12 points on the same position. Let's make it that we're only adding in points every 12 frames. So let's do a delete geometry node. And as the selection, we want to take this scene time, the rep, and the equal node. So let's take those and let's connect them with the selection. And now if we start playing the game and we go to 1 length and we preview this as the tail, then you see that we only have 11 points. So basically what we should do is over here, this equal should not be equal, but it should be not equal, so to say. And now if we play it, we will get that when we get to 1 point and we preview it over here again, then we're getting just 1 point right over there, which is perfect. So let's make a little bit more space again, and let's rename this part to only at 12 frames. So if we start playing now, maybe at some point we will see, yeah, there it is. The apple got spawned at the same position as the tail was. And that's not what we want. We want to make it impossible for the apple to be spawned at the same location as the tail. And we're going to do this by literally deleting the parts of this grid that are colliding with the tail. And to get the collision, we're going to do a geometry proximity node. And we're going to set this on points because the tail consists of points and the target needs to be the last delete geometry of the tail part. So let's take that and connect that as the target. And let's make a little bit more overview by moving all of this and then that. And let's move this part more to over here and a bit more like, yes, perfect, like that. And with this geometry proximity node, let's do a compare node again. And let's set this on equal because we want to delete the grid parts that have a distance equal to 0 to the tail. So if we do a delete geometry right over here and we connect this also with the attribute statistic, we can put this equal part over there. And then let's set the delete geometry over here on face because we want to have this working in the face domain, and set this on only edges and faces so that it doesn't delete the points, but only edges and faces. But then you will see that it doesn't really work because the apple goes immediately to the middle over here. That's because this deleting process only works if the length is longer than 0 and not if it starts already at 0, for example. So let's make it that it only works for a length of higher than 0. So let's do this by adding in the named attribute of length again. And this named attribute, yeah, we cannot just do that, use that over here because this grid doesn't have the attribute length. Only the snake head has an attribute that is called length. So we need to extract the length attribute from the snake head onto the grid. So we can do this with a sample index node. And the thing we want to sample is the length value. And the geometry from which we want to get that length value is going to be the snake head geometry. So if you connect that over here, then that's good. The index, we don't have to do anything with that because an index of 0 will automatically be the head part. And then if we move all of this a little bit to the front and the sample index, we want to say, okay, if that with a compare node is greater than 0, then the deleting part should work. So if we do a math node and we set that on multiply and we multiply this output of the distance with the output of the greater than length, and we connect that with the delete geometry, then we should be able to see that it starts working. Yes, exactly. As you see, this works perfectly. And now the apple will never be on the same position as the tail of the snake. Another rule within the snake game is that you're not allowed to move backwards. So in this case, from here, I would not be allowed to move backwards. So let's make it that from here, we are only capable to move forward, to the right, or to the left. And we're going to do this by manipulating this value over here between the store named attribute of the direction and the multiply node of the controller nodes. So let's add in first a mix vector node right over here. The vector is going to be the determination whether the new direction given by this multiply node is the inverted direction of the direction that we were already doing. So basically, if this is our old direction, the new direction is not allowed to be backwards. And to get the inverse direction, we should do a named attribute and we take the direction over here. And to get the inverse of this, we want to do a vector math node, which we set on scale. And we want to scale this by -1. And now we basically have the inverse of the previous direction. And now if we add in a compare node, which we set on vector, we can say, okay, if the inverse direction is the same as the new direction, then it should stay the old direction. So connect the compare node with the vector. And now we should not be able to move backwards. So if we're now going like this, then you see, oh, we are capable of moving back, right? That's a bit weird. And actually that is quite logical because this direction attribute is now updating every single frame and not every 12 frames. And that's actually what we want, because if we do it every single frame, then for example, if we go from this direction to this direction, it will first switch to this direction over here, because over here there's a small part over there. So let's change it that this direction value only changes every 12 frames as well. And to do this, let's take this mix node, shift D it over here, and let's take this named attribute over here and take it like this. The value of B should be the mix node. The value of A should be the old direction. And now the vector is going to be the part that we used before again. So this scene time, the rep and the equal, so that we can say, okay, every time we are on a 12th frame, it should update the direction. Otherwise, it should stay its direction. And now you will see that we are not capable of moving in the opposite direction anymore, which is perfect. Okay, we're already pretty far with our snake game. However, it cannot be game over yet. So let's add in the conditions that it can be game over. The first condition that we're going to set is that the game stops whenever our head is outside of the grid. So to do this, we're going to create a new store named attribute over here, like this, and we name this game over. And we want to update this over time. So we do a named attribute again. and we call the game over. So we do game over like this, and we connect that like that. And we want to add something. So we do a math node like this. Because this attribute, it starts off as 0. And we want that when the snake leaves the grid, that 1 is added, and we say, okay, it's game over. And to determine that it left the grid, we can take this group input and the grid again, and shift D it all the way to that store named attribute. And then if we do a geometry proximity node, and we connect the grid as the target, and now we have the distance from the head to the grid. And this distance value with a compare node, we can say, okay, if the distance is not equal to 0, then we want to add 1 to game over. And to preview this, we can do Ctrl-Shift-Click on the store named attribute and Ctrl-Shift-Click on the named attribute. And then if we press play, you see we start off as a false, but when we leave the grid, it becomes a true value for the point, which is good. However, it's not stopping yet. So let's make it stop when game over is true. We do this by going over here between the update 12 frames and the don't go in opposite direction parts. And we simply do a mix vector node, and we want to either get this direction or it needs to be 0, because if it's 0, then the thing is not moving anymore. So now if we do a named attribute and we call the game over attribute and we plug that in to the vector, then it should be that when we press play and it goes out of the grid, you see it stops and it's game over. Now going back to here, we can make this a frame again. So we then can do Ctrl J and we can name this game over if out of frame, like that. But there's one more condition that we need to have, which is that the snake should not be able to bite its own tail. So to do this, we're going to copy this game over attribute again, and we're also going to do the same thing. So named attribute and then game over, and we're going to put it like this, and we're going to again do the math node, because we want to add a certain condition to it. Basically, we want to make this game over value true if the position of the head is the same position as the position of one of the tail parts. So we do a geometry proximity again, which we this time set on points because the tail consists of points and the target is going to be the tail. So let's go all the way to the beginning and let's take this tail part, the snake tail, and let's connect it all the way over here with the target of the geometry proximity. And then we want to say with a compare node, we can say, okay, if the distance is equal to 0, so if the distance from the head to the tail is equal to 0, we want to add a part. And now if we do this, you will see it stops immediately. And I couldn't really find the real reason why this doesn't really work. So if anyone has any ideas, comment it down below. But I did find a solution. If we make it that this part only works if the length of the snake is higher than 1, then it works. Then we don't get this kind of glitch anymore. So if we do a named attribute and we do a length, and if we say, okay, if the length is greater than 1, then it should work. So if we do a math node, which we set on multiply, and we multiply this equal node with this greater than node, then you will see that it works. So then it should be that if I now play it a little bit and I make myself that, yes, then you see it stops playing, and because I touched the tail. And let's make this into a frame too. So let's take this, Ctrl J, and let's make this game over if touching tail. So at the moment we actually have a fully working Snake Apple game. However, it doesn't really look good, right? So let's make this actually look a bit more appealing. And we're going to do that after the simulation zone. Let's make a bit more space like this. And I'm also going to play the game a little bit so that the tail is long enough to make it look good. So I think this should be good. Yes. So what we want to do is we want to convert these points into a curve. So that it will be very easy to make this look like a snake. So to do this, we're going to do a points to curve node. And the points is going to be the snake tail, like this. Now if we disconnect the snake tail from the joint geometry and we connect the points to curves, you see we're getting a curve that connects the points. However, you see that the head is not connected with the curve. To make this happen, we can do a join geometry. and we join the snake tail with the snake head. In this case, it is important that you make the join of the snake head above the one of the snake tail, because if you do it reversed, then it will look like this. It will connect it with the end part of the snake, and that's not what you want. So connect it like this. Now to make it that it looks like the snake is making smooth curves, we can do a fillet curve. I have no idea if I pronounce that right, but let's do a fillet curve. Or fillet, I have no idea. And we're going to set this on poly. And then if you set the count higher, you will see, okay, it's already doing something. But then let's also do limit radius so that it only can do it like this. And if you want, you can change this so that the radius is a bit lower so that you get more straight parts. I like it like this. And then a count of 5 is good because the count makes it, okay, how much should it be beveled like that. Now let's give this thing a bit of thickness with a curve to mesh node. And as the profile curve, we want to do a curve circle. And let's connect that like this. Then you see, okay, looks good already. However, let's make it thinner with a set curve radius node. And to be honest, yeah, we can do it like this, of course. However, I want that it stays thick over here, and in the end, it becomes like a round thing, so to say. And we can do this by adding in a spline parameter node. And if you connect vector with radius, then you're getting a huge thing, of course. But let's do a math node and let's divide this with a higher number so that we can see it a little bit better. We now have that it goes from 1 over here to 0 over there. I want to switch this, and we can switch this with a float curve node. This float curve node now goes from 0 to 1, but I want this to go from 1 to 0. And you see it goes like this. Not so beautiful yet. I think it would be good if we make this only in the end become smaller. And to make the whole thing look a bit more smooth, we need to have more resolution on our curve. And to create more resolution for our curve, we can do a resample curve node. And let's set this on length actually, because then if the curve becomes longer, the resolution will kind of stay the same. So if you set the length on 0.01, then you see we're getting it quite well. I think it's a little bit too thick, so I'm going to make the divide node lower. And then you see we're already getting a very nice looking snake. Plus, it still works. So if we play the game like this and you see that it starts growing, let's wait a bit, yes, like that. And you see it works perfectly fine. The model that I will use for the snake head will be this model. And to get it that this point becomes that model, we're going to do an instance on points node. And then as the points, we're going to do the snake head. And as the instance, I'm going to drag the snake model over here. And I'm going to connect it as the instance. And now if we disconnect the snake head from the join geometry and we connect the join geometry with the instance on points, then we're getting this. Obviously, this is not good yet. First of all, we can change the scaling to be a little bit smaller like that. Plus the direction in which the head is pointing at never really changes. We want the direction in which it's pointing to be dependent on the direction in which we point our controller. So to do this, we can do a named attribute that is the same as the direction attribute that we created before. And then we want to align the rotation of the head with the vector of the direction attribute. So if we do an align Euler to vector node and we set as the vector the direction, we can put the rotation into the rotation. And then you will see that we have to put not the X value, but the Y value on, because you see, then it goes in the right direction. However, it's inverted. So let's invert the rotation of the head with an rotate Euler node. And let's rotate this one on the Z-axis by 180 degrees. And now it will go always in the right direction. Perfect. Maybe you're using a different snake model, then it might be that you use a different align Euler to vector or a different rotate Euler or a different scaling value over here. But that really depends on your own project, so to say. Now you also see that the snake head and the tail of the snake are colliding with the grid, and we don't want that. I want that it's kind of like above it. So let's do it like this. After the curve to mesh, I want to do a transform geometry node, and then we can put the Z translation up a little bit. I want to do this at the same time for the head. So what I do is another join geometry before the curve to mesh, and I join the instance on points with the curve to mesh before the transform geometry. And then you can disconnect this one, and now you see you have better control over it. And then you can do it like this, for example. Now for the apple, I'm going to use this model. And what we will do is the same thing as we did before with the snake head. So we're going to take this instance on points. Let's duplicate it. And let's, as the points, let's add the apple like this. And as the instance, let's drag in the apple model. And let's connect geometry with instance. And then we can again connect the instance on points with the join geometry. And we can disconnect the apple. And then you see the apple is over there, which is perfect. You can make it bigger or smaller, whatever you prefer, but it's over there, which is good. Obviously now if we go into material preview mode and we turn off the wireframe again, then you see, okay, the material of the apple is good. The material of the head is also good. However, the tail doesn't have a material yet. So let's give the tail the same material as the snake head, or just any material that you like, of course. So let's do a set material after the curve to mesh, and let's make that the snake material like this. And another thing, if you're going in material preview, then you don't really see the grid anymore. So if you want to see the grid, then what you can do is convert the original grid to a curve. So do a mesh to curve node, and then give this thickness with a curve to mesh node. And as the profile curve, you do a curve circle. So like this, and then make that a lot smaller, of course, so that it actually looks better. And then you could also join the original grid with the join geometry so that you have it like this, and you can still see the grids of the playing field. And still it works perfectly, the game. So if you start playing, yeah, you can still do that, of course. Yeah, it works completely fine. Perfect. Now the last two things that I want to do is that we can see the live score of the game and that the game shows when it's game over. So let's first do the score part. So for the score part, we actually have that. We have that as the named attribute length. So the length is basically the same thing as the score. However, we need to get the length value from the snake head. So we're going to do the same thing as we did before with a sample index. We can retrieve the length attribute from the snake head. So if we put that like this and we put the length over here, then the output of the sample index is the score that we want to display. So let's do that a bit over here. And now we're going to play around a little bit with strings, which is fun. So first of all, we want to do a string to curves node. And that's really cool because now if we connect this with the join geometry, for example, and we just type something, then we're getting the text something as a curve. But we want to get this value as the curve. And that's not going to work right now because we have to convert this value into a string. So you can do a value to string node. And then if you connect this over here and then over there, then you see we have live the score of the game. So now it's 7 and then it's 8 and then it becomes 9 and then it becomes 10. But we can make this a little bit more beautiful, of course. So what we want to do is I want over here score 10, for example. So let's make another string value, which we name score. And to join this one together, we can do a join strings node and put them like this and put the score above the value string, because otherwise it will be reversed, of course. We don't want that. We want that to be like this. And then I forgot over here in the score, I forgot to do this part. Of course, if you want to have a space between the 10 and the score, you can, in the delimiter, you can do spacebar, and then there will be a space between them. Let's make this into a mesh. So let's do fill curve node, and let's then also extrude this out so that it gets thickness with an extrude mesh node. Let's make that a little bit less, like that. Perfect. Now in the string to curves node, if you set left to center, then the score will be in the middle, which is good. And you can also make the size less so that it's as big as the grid, kind of. And you can also do a transform geometry to put it a bit more up so that it's over there. And now if we start a game again, you see we always have the score right over there. And again, of course, you can give the score any color that you want with a set material node. Now you see, oh yeah, it's game over for me now, right? Because I'm out of the field. But the game doesn't tell me that it's game over. So let's create that it tells us that it's game over. So to do this, we're going to do another string to curves. So let's take this one and duplicate it above where we have space. And let's make this, instead of something, let's make this game over. The output of this node should appear when it's game over. So what we do is a delete geometry node. And this string to curves should be deleted as long as the game over attribute from before is false. So if we do a named attribute, which we set on game over, then we can set that like this. However, we have to do the same thing as before with the length over here with the sample index. So let's do a sample index so that we can retrieve the game over attribute from the snake head onto this string to curves and then connect that like this. However, if we now connect this delete geometry with the join geometry, then you will see that the game over is always there until it's actually game over. So to reverse this, we can do a map range node. And right now it goes from 0 to 1. But if we make this go from 1 to 0, then we reverse it, then it will be like this. So now we're playing, and it's game over. And now to make the game over letters look a bit better, let's take the fill curve node and the extrude mesh node over here, shift D them to there, and connect the delete geometry of the fill curve, and disconnect this one, and connect the extrude mesh with the join geometry right over there. And you see that looks like this. Just for visual representation, let's do a set material node, and let's name this material red, and let's make it red. And then in the set material, we can do red, so that the letters of the game over are red and you can clearly see it. This way you can give any component of the game a different color to whatever you prefer, of course. So now you know the fundamentals of creating a simple game using Blender. And as you saw, it's not that hard. The most important thing is that you have a clear vision of what the game is going to look like, with those 4 steps we looked at earlier. Together, of course, with like a lot of practicing, but over time, that should be fine. I do quickly want to mention the big notebook again, because I think it's an amazing tool that everyone should use. So go to the link in the description to get your copy today. And if you like this video, please give it a thumbs up, comment down below if you have any questions, and if you don't want to miss out on any future videos, I recommend subscribing. And with that being said, I see you in the next one.